Hi, everybody. This is Mr. Folly, and welcome to podcast 2.1 Electrons. We're going to learn how we count for electron configurations. So get a PT, that's a periodic table, out right now. So we're going to learn about off-ball, and we're going to learn about electron configurations, noble gas configurations, excited state configurations, and ions. So let's boogie. Atoms come with electrons, but it's helpful to think of atoms as adding electrons one at a time. So normally they come all at once. So if you think of a baby doesn't first grow a head, then grow a foot, then grow whatever it is else that babies grow. But you get the idea. This means we need a filling order. So if we think of it as adding one at a time, we need a filling order. And the off-ball principle says this. The off-ball principle says add electrons to the lowest energy level first. Why do we add it to the lowest energy? Because that is the most stable. So if you want to say someone is stable, they are low energy. If someone's high energy and freaking out all the time, woo, 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 they're the ones that might jump out of the window. All right. Oh, come on. You change when you don't want to all the time. The periodic table shows this. I'm going to add the word filling order. And it goes up here. So it starts here. Here's step 1. Here is step 2. If you're looking at the periodic table, this should make some sense to you. And it goes through here. There's step 3. And then it gets kind of crazy. But that'll give you a good idea. The blocks of S. Okay, so these have blocks. I've tried to shade them, but I didn't do a very good job. This area right here is the S block. Shut up! That's the S block. This area right here is the P block. Hopefully that's pink, and P can stand for pink. Okay? The green part is the D block. And the dark blue part down here is the F block. Okay? So don't be surprised if I say, draw a periodic table, label the S, P, D, and F blocks. And you should be able to do that. Draw a periodic table? Yeah, we're going to draw a periodic table. All right. How many columns are in the S block? Well, let's look back. See this? You have a light blue and a red. How many columns are in the S block? 2. How many electrons fit in the S block? That means 2. So 1s2 means that 2 means I have 2 columns. Okay? So if I look at this, let's see if I can erase some of these. Make it a little cleaner. This would be S1. Everything in here is S1. So it's like a coordinate. So this would be 1s1. And down here would be S2. All the way down would be S2. So there's no such thing as a 1s1. Okay? So if this is the P block, this would be 1. Well, this wouldn't be 1P. Oh, why can't I have an eraser when I want one? Oh, you dirty dog. Oh, do I hate you? I hate you so much, computer. This is P1. This is P2. This is P3. And there's 6 columns that go all the way to P6. Okay? All right. So 3s2 is different how than 1s2? 3s2 is on the 3rd row. So this number right here in front will be the row. How many electrons are in the P, D, and F block? 6 in P. Oh, now you change signs. 10 in D and 14 in F. And if you go to the periodic table, this has 10 columns, 6 columns, and 14 columns. All right. Give the electron configuration. So the best way to do this is just do it. So my first hope is that these lines go away, but I don't think they're going to. Carbon is number 6. So I need to start with number 1. So on the periodic table, on number 1, I'm going to, well, you know what? Let me actually see if I can end this. End show. Discard. You better believe it. And I am going to go off script here. Woo! Here's a periodic table. I told you I have to draw one. Look at that. Right here. Okay? So I'm looking for carbon, which is right around here. 1s2. This is 1s1. This is 1s2. Second row is lithium and beryllium. See how they're still in that new block? I'm now in the second row. See how I'm on the second row? I'm back in the S block, And lithium is 1, beryllium is 2. The next ones are boron and then carbon. Well, I'm still in the second row. And now I'm in the P block. Hey, look at me, I'm in the P. And then P1 would be boron, P2 would be carbon. There's the electron configuration for carbon. Isn't that crazy? Ooh, I love it, I love it, I love it. Then we'll look at SM. Let's see if I can get my right on periodic table up. That's what I should have had up before. Right on periodic table. Review. So let's go ahead and do SM for you. SM is a little beastie that is number 62. Okay? So for number 62, I'm going to start off the same. This part right here, 1s, S1, S2. This part of this block, second row, first row, second row, third row, fourth row. Second row, S block, 2. Whee! Second row, remember this is the P block, 6. Now notice, this gets me to number 10. I'm going to SM. SM is 62. Wow, that's almost Social Security age. Okay. Now I'm done with 10. Now I have to do 11 and 12. Doink. 3s2. 13 through 18, 3p6. 19 and 20. Whoa. 4s2, and now we have the star. Need to take notes and not just write down this answer. D's have one lower front number, and that front number is called an energy level. So if it's one lower, instead of this being 4D, this should be 3D. Whee! The D's stop right here. 3D10. Okay? Then the P's jump back up to their rightful level. 4p6. Are you tired of this yet? I almost am, but I love it. Oh my goodness, I'm on the 5th level now. Look at me. 5s2. Oh man, another D. It's not 5D, it's 4D10. Am I at 62 yet? Not yet. Oh, doggies. Back on the 5th row, 5p6. 55 and 56. I'm on the 6th row now. 6s2. Now, see 57? Here's 57. That would be 5d1. Uh-oh. Where's 58? Oh, here's 58 to 62. Yikes. Now, this is easier to label than do anything else. This whole line is 4f, and this whole line is 5f. Okay? So this would be 4f. 1, 2, 3, 4, 5. 4f5. Come on up. 4f5. Man, is that a honkin' long electron configuration. Now, what I want you guys to be able to do is realize that there is a shortcut for this bad boy. So the shortcut for this bad boy is what we really only care about is the outermost level. So I need to find myself the biggest number, biggest energy level. Front number is the energy level. 1, 2, 2, 3, 3, 4. Hey, 5, 4. Hey, 5. Hey, 5's the biggest. No, 6 is the biggest. See how this is the biggest? That means these are the ones we care about. So instead of writing, as soon as I get to my biggest one, up to 5p6, 1, 2, 3, 4, 5. This was 5p6. Okay? So instead of writing all that junk up to 5p6, I write that element. These elements are called noble gases. Hi, I'm a noble gas. So this is called a noble gas notation. So instead of all the junk up to 5p6, I just write the noble gas Xe. See how that takes care of 54 of them? 54 in brackets, and then 6s2, 5d1, 4f14. Okay? So I'm going to hop back onto this guy. You just saw me do that. This is the shortcut. Whoa. There's a lot. Whoa. There's a lot of repetition, right? So a way is developed to show the outer electrons only. The valence, this is new definition, the valence electrons is S and P. The other blocks are core. The valence electrons, valence is S and P. I'm going to add the word outer. S and P and the other blocks are core. Core notation is synonymous with noble gas notation. So notice our core notation, that's xenon is our core. Work out your core, man. And then the valence electrons, if I want to know the valence electrons for those other ones, I think it was just 6s2 that was the outer S and P. There was no 6p0 if I was a weirdo. But that would be my outer ones, and that's it. For the following, do calcium. I'm not going to do both. I'm just going to do shortcut one because we'll do a lot of these in class. So calcium is number 20. So looking at the periodic table, I'm going to do 1s2, 2s2. So again, 1s2 is the top row. 2s2 is that bottom row. 2p6 is from boron, number 5, to neon, number 10. 3s2 is sodium and magnesium. 3p6 is aluminum to argon. And then 4s2 gets me to calcium. So notice 2, 4, 10, 12, 18, 20 tops add up to it. Okay. Now the core notation, look, all I care about is my outer one with the big guy on there. Stop it. Okay. So 3p6 was argon. Okay, so I'm going to write argon in brackets, 4s2. Pretty easy, huh? I think so. Okay, dB, I don't want to look for dB because I already want to stop with this. So I'm going to instead do BA. Nah, sorry, dB. BA. So if I do BA, I am going to look at the core notation. So the preceding noble gas of number 56 BA is number 54 xenon. Okay, so I'm going to write xenon, which gets me up to 54. 55 and 56 are on the 6th row, S block. 2 of them. Woohoo! That's it. Oh, look out. Positive ions lose valence electrons, and negative ions gain valence electrons. So aluminum plus 3, I'm going to write this faster than you can. 1s2, 2s2, 2p, where's aluminum? 6, 3s2, 3p1. Now, if I'm plus 3, positive ions lose them. I'm going to lose 3. Hey, look, here's 2, here's 1. These get axed. So aluminum plus 3 is 1s2, 2s2, 2p6. Okay? Neon, if you look at neon, is also, we'll get back here. Neon is also 1s2, 2s2, 2p6. Hey, they're the same. The word for the same electron configuration is isoelectronic. Hey, that means the same electron configuration. Okay? S negative 2. So S has 16 from the periodic table. This negative 2 means it gained 2, so it has 18. So it has 18 electrons. It's the same as argon. Look at your periodic table. 18 is argon. So I'm going to do a little shortcut here. Neon, right? 3s2, 3p6 is the ion. Neon, 3s2, 3p4 is atom. No charge. So is S negative 2 is isoelectronic with what positive ions? So that would be K positive has 19 electrons go to 18 electrons. And so does calcium plus 2. Has 20. Go to 18. Bohr says electrons can jump up. Jump. Crisscross makes you want to jump, jump. So you can have the first excited state for silicon, which would be the noble. So first I'm going to write silicon, which is neon. 3s2, 3p2. Now if it's excited, one of these jumps up. So it turns into neon, 3s2, 3p1. After 3p comes 4s, 4s1. Crazy. First excited state for krypton. Krypton is argon, 4s2. Yeah, 4s2, 3d10, 4p6. Sorry, that's a 10. And then excited is argon, 4s. Oh, get back here. 4s2, 3d10. Take away 1, 4p5, and put it in the next level, 5s1. A few more rules about electrons. Hund's rule. Electrons can reside in bundles of up to 2 called orbitals. Orbitals of equal energy will put 1 electron in each before any orbital gets full. Oh, helping Hund. Another way to look at it is inspired by a real sign at the University of Illinois. Applies better for the dudes out there. You should always choose the urinal, which gives you both you and the other people in the bathroom the most buffer room. So if here's a urinal, and here's a urinal, and here's a urinal, dudes give themselves the buffer room. See, you don't go back to back. Of course, you don't really go backwards on that. So orbital notation of nitrogen. Nitrogen has 7 electrons. Up, down. There's 2. Up, down. That's another 2. That's 4. Now I have 3 left. They go up, up, up. So a box can hold 2, but it only wants to hold 1 at a time if it can. So electrons are arrows and boxes are orbitals. These are clouds. Wow. Orbital notation of magnesium. So magnesium has 12 electrons. So it's sometimes easier to write the electron configuration first. 1s2, 2s2, 2p6, 3s2. 1s2, box me. 2s2, box me. 2p, box, 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 and then 3s, box. So if it's 2, whoops, up, down. 2, up, down. Now 2p6, here's how you fill them. Oh, get back here. Up, 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 down, 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 up, down. And you have to fill in that order so that they don't, so that it minimizes repulsing. Full means we're stable. Noble gases don't react because they are full stable. I even like to make it a word, full stable. And if you did orbital notation for krypton and neon, if you want to believe me, they are full boxes. All boxes are full. Oh, well, I'm not doing that. So it's an orbital reeling a box. No, it's a cloud. S is a sphere. Hey, P is a dumbbell. I don't know why they call that dumbbell. D is complex. F is complexer, and a grade you want to absorb. You only need to draw that one. It's a sphere. It's a circle. Having single electrons affects magnetism. How many single electrons does carbon have? So if I do the orbital diagram, I'll get back here. 1s, up, down, 2s, up, down, 2p. Carbon has 1, 2. Now carbon has 2 electrons in here. If I put it in here, I'd be wrong. That's wrong. That's wrong. Because Hund says we have to share it. And I doubt this. Let me erase it. Hey, let me erase it. That makes me happy. So I would do this. So this has single electrons. Okay? So carbon is a wee bit magnetic. Review. SPDF. Noble is shorter and your friend. I know. Okay, yeah, noble is your friend because it's shorter. Yay, it doesn't take as long. Valence electrons are outer S and P only. Ions are isoelectronic with some other ions and an atom. Orbitals are like boxes but are really weird shapes and toodles.